Okay, morning everybody. So we're gonna make a little video here on how things are gonna change for the 2020 AP Physics C mechanics and E&M tests. The AP Physics 1 and AP Physics 2 tests are actually gonna feel a little similar to what they have in the past in terms of kind of what they're asking. Those have changed well, and we'll talk about it. But due to the whole COVID-19 thing, the AP Physics C test is changing drastically to an extent in order to kind of facilitate you being able to take this test at home. So here are some notes I've been making over the past 2 weeks about kind of what I've heard, what teachers are thinking of. And here's what we know from the College Board. Let's see, where am I at? We know that, here we go. So for the Physics C tests, it's going to take place on May 11th. And if you're in the Eastern time zone, which I am, this test starts at high noon for you, which is great. If you're out in Hawaii, I am so sorry for you. This test starts at 6 a.m. That is terrible. I'm not ready to do math or even think at 6 in the morning. I'm like just getting in my car to go to work on a normal day. But if you're Eastern time or kind of like down to Pacific time, 9 to noon, that's not bad. There's only going to be 2 free response questions. That's it. The first question, they've segmented a little bit more time for. It's a long free response question, and it's asking you to analyze, to determine scientific questions and methods, analyze some data represented possibly in graphs, and develop an explanation or a scientific argument. We're going to take a look at kind of what one of those would be like. Our second question is a short free response, and it's what we call the lab question. There's going to be some lab that maybe a student has developed this lab and they're asking you for opinions on it. They're going to ask you, does their data make sense? Why doesn't it make sense? What could you do to change the lab? So we'll talk about those. This question setup, the first long question, more of an analytical question, and the second one being a lab, is the same for both the AP Physics C mechanics and the E&M test. The first question is that long free response question, analyzing, kind of doing a problem, and then the second one being the lab. The C E&M test takes place at 2 o'clock after the mechanics test on May 11th. The difference here is that the test is only 45 minutes, so if you start it at noon, you finish at 12:45, and you have like an hour and 15 to kill, so you can like go get some food, drink another energy drink, go to the bathroom. So you've got some time to kill there. But both of them are just 2 questions. For the AP 1 and AP 2, AP 2, which we're looking at, is May 13th, and it's at high noon. It's the same kind of thing, although one of these is a quantitative translation question. They're basically going to be asking you to write some stuff, which is typical for the AP 1 and AP 2 tests. And then the second one is the paragraph short answer, which is also pretty typical for the AP 1 and AP 2 tests. So a little bit less math, a little bit more writing, but you're still going to have to do a lot of writing on the APC test this year, simply because they don't have a good way for you to put your math into the computer. You're going to be sitting in front of a computer with a keyboard. Like, you don't have one of these fancy writing tablets like I do. You can't write into it very well. So they're going to have to kind of structure you through a problem. And what we're going to look at right now is the 2017 AP Physics 1 test, which is actually a really good example of a Physics C question, but turned into something that we could answer for this kind of year. So this is the 2017 AP Physics 1 free response question. It is an AP 1 question, but remember, AP Physics 1 is AP Physics C mechanics, but just without the calculus. And the calculus doesn't even always appear on the mechanics test in every problem, so we might not see it as much anyways. In this problem, we've got a disc hitting a rod with a pivot point about pivot C, and if we kind of look at this, the rod's initially motionless, but it's free to rotate around the pivot. Student slides the disc with velocity v naught perpendicular to the rod, and it's going to stick to the rod at some distance x from the pivot on the left-hand side. Okay. I guess this is the center midpoint of the rod. Excuse me. This is the midpoint. The pivot's on the left here. And then they start asking you questions and asking you to kind of analyze this. This is what we can expect from the Physics C world this year. It's believed, at least. A good hunch is that they'll do something like this. They're still going to ask you to really think about this problem. Suppose the rod is much more massive than the disc. To give the rod as much angular speed as possible, so as much rotating speed, should the student make the disc hit the rod to the left of point C, over here, at point C itself, or to the right of point C? And then beliefully explain your reasoning without manipulating equations. So if we just kind of think about this and kind of talk through it, and talking through it is an excellent exercise to do this. If you're looking at the other physics problems that are on the Coach Botzer YouTube page, or you're just finding AP problems and trying to do them, a great way to prep for this year is, no matter what kind of problem it asks you, talk through what steps you would be doing. Don't actually do the math, because we might not have to do that this year. Start with just, here's what I want to do, here's why I want to do it. And then go try the math out, because the math is the math. For something like this, if we wanted to argue it, if I want this rod to pivot as much as possible due to the disc, then I should probably hit it to the right of point C, as far as possible, in fact. And the reason being is that this disc is going to impart its momentum onto the rod here, and if I hit it further away, I have a longer moment arm from the pivot, and therefore the force that's being applied here has a longer pivot to go across, and I can provide more torque. Torque equals I alpha, and I can cause that rotation there. So, maybe something like that would say, like, it would give you a justification of why you'd pick the right, and then here's your explanation about what's going on there, without manipulating equations. Because, to manipulate an equation for that might be kind of difficult, because you're saying, like, well, like, maybe if the disc is moving here, like my moments arm longer for more torque, but, like, whenever this disc hits and sticks, there's a longer moment of inertia that it's adding with the parallel axis. But yeah, so you're just kind of reasoning things out. And we see as we go down to the next problem, part B, we still get this kind of, something is occurring here, and we have this equation that the student has found. So maybe we're kind of like in a pseudo lab analysis. So this is some equation a student has found to determine the angular momentum, or the angular velocity, excuse me. Regardless of if this equation is right or not, like, who cares if it's right? This is what they found. Does it agree with your reasoning in part A? So this is just like a matching to part A. Does this make sense with what you have done? And if we're saying in part A that as we get further and further away from the pivot, a greater and greater x all the way to the end, if that's going to make this rod spin faster, then if I look at this here, omega equals the mass of the disc, the velocity, there's a moment of inertia. As x gets bigger and bigger, because it's in the numerator, then omega gets bigger and bigger. So yes, and that would be y. So I didn't need to derive anything. I just need to say, like, look, x is in the numerator here. It's increasing as I move further away from the pivot. This is a linear relationship, based on m, v naught, and I, that will increase with my position of x. So we're not really solving this problem. We're just kind of responding to it and kind of giving our reasoning to what's going on. And we can expect that to be the way that the College Board is going to be looking at this year. That's at least everybody's hunch. We're 100% like, well, I shouldn't say 100%. We're like 70% confident that this is what it's going to look like. Because there's no way that they can ask you, like, set up a big math problem and write that down and then upload it into the computer, and you've got 45 minutes to do this. And we just don't think that that's what's going to happen. We think something more akin to this, and the College Board has recommended this problem as a good problem to look at, which hints from them that we could be seeing something like this on the rundown. So definitely take a look, if you haven't, at the 2017 AP Physics 1 free response question. Another question that's pretty good is the AP Physics C 2012, the second question. That's a pretty good one as well in terms of lab questions. That one is designing an experiment for mechanical energy. So it's pretty similar in that regard. So that's what we kind of expect out of the mechanics. For the E&M test, what we're actually expecting is the first question to still be some sort of Gauss's law, but we think that they might make it a Gauss's law problem with a capacitor. So we might have some sort of like cylinder that goes like this, and then a cylinder on the outside of it with maybe a dielectric in the middle. So here's some blue dielectric in between them, K. They could do something like that where they ask you to Gauss's law like the inside and then figure out a capacitance there. And instead of asking you to derive Gauss's law, what they may have is they may have like a few equations and say which of these is the correct setup for Gauss's law. So you might still have to like derive it on paper to like get what one of them, but if you're familiar with Gauss's law and how things should be looking, you might be able to just look at this and be like, bam, it's that one, I got it, and then move on from there. So this is what we think, because we know they love Gauss's law and it's still on the test. The first question is normally something regarding it, but they also need to include capacitors somewhere, so it might be in that first question. And that's that long 20 minutes question there. I think it's 25 minutes question mark. Yeah, something like that, whatever. The second question, that's the lab question. We think that's going to be circuits based. Traditionally, the College Board likes making AP Physics C lab questions circuit based because a lot of people deal with labs. So you should definitely be looking at circuits and trying to get some ideas of, where would you put a voltmeter? Where would you put an amp meter? Because you could describe that. I would put the voltmeter between R1 and R2. That'd be a poor spot to put it. So I'd say I'd put the voltmeter in parallel or across R1 in order to measure the voltage drop across R1. Like, you want to be able to kind of talk about that in that way. But we really think the lab question is going to be about circuits here and kind of talking about those. In that regard, maybe it's a good idea to think about RC circuits. How will the capacitor charge or discharge? Charging up, discharging down. So you can kind of describe those curves. If you're talking about LC, you're talking about oscillations. You want to be able to talk about those oscillations there. What they're really probably going to ask you is how things like RC, LC, RL circuits act at short and long times. How do things act immediately when the circuit is open? How do they act a long time later after the capacitor is charged or after the inductor has current moving through it for a long time? So those are the kind of things that we can expect out of that APC question, but we'll just have to see. But that's what people are guessing right now. That's what I'm guessing on how things are looking. And in either way, being able to kind of talk through and describe what you're doing is very important. It's the important thing for this year. For the AP1 and AP2, the test itself really has not changed in that regard. Like I said before, you've always been asked to kind of assess students' ability to kind of do a little bit of math, but it's a lot of justification. And you always have had to do a paragraph short answer response kind of thing. So nothing's really changing there. So if you're still able to kind of talk through what you want to do in a problem, just like we saw here, then you should be good. This is an AP1 question because this is what the AP1 looks like. And if we look at some other things from AP1, they all kind of look like this. How would you describe an experiment? How would you do this? There's a little bit of math here, but they're probably going to take that out for this year. So yeah, the AP1 questions are probably going to look, or they're probably going to be what the APC questions look like this year, because it's the same content, just a kind of a new way of answering the question itself. So hopefully that gives you a little bit better idea of kind of what to look at, what to see, how to be thinking about these questions. And like I said, you can find other AP questions that aren't AP1 that look like this. You can find APC questions, but really talk about them. Try to work through your answers verbally or write down your answers and what you plan on doing, and then go and do it, because that what you plan on doing might be what we need to put this year on this test as things have changed up due to the whole COVID-19 scenario. So hopefully that gives you some insight to the problem that we're facing together, and hopefully you do great on that test. So best of luck, keep studying, take it easy.